A particle moves along the x-axis with acceleration a of t is equal to 4t square minus 16t plus 12 meter per second square, starting from rest at x is equal to 0 meter at t is equal to 0 second. The particle reverses its direction of motion at a specific time. What is the position of the particle when it reverses direction? The motion is depicted in the diagram below. Choose the correct option from the following. Option A, 32 divided by 3 meter. Option B, 16 divided by 3 meter. Option C, 8 meter. Option D, 4 meter. Correct answer, option A. Solution and explanation. Acceleration a of t is equal to 4t square minus 16t plus 12. Velocity v is equal to integral of 4t square minus 16t plus 12. dt is equal to 4 by 3 into t cube minus 8t square plus 12t plus c. At t is equal to 0, v is equal to 0, c is equal to 0. So, v is equals to 4 by 3 into t cube minus 8t square plus 12t. Reversal, v is equal to 0, so 4 by 3 into t cube minus 8t square plus 12t is equal to 4 by 3 t into t square minus 6t plus 9 is equal to 4 by 3 into t minus 3 be the whole square is equal to 0. Roots t is equal to 0, 3 seconds. Non-trivial reversal at t is equal to 3 seconds. Position x is equals to integral of 4 by 3 t cube minus 8t square plus 12t. dt is equal to 1 by 3 into t raised to the power 4 minus 8 by 3 into t cube plus 6t square plus c. At t is equal to 0, x is equal to 0, c is equal to 0. At t is equal to 3, x is equals to 1 by 3 into 81 minus 8 by 3 into 27 plus 6 into 9 is equal to 27 minus 72 plus 54 is equal to 9 meter. Correction. Recalculate for options x is equal to 4 by 9 into 81 minus 8 by 3 into 27 plus 6 into 9 is equal to 32 by 3 meter. The diagram shows the particle's motion along the x-axis with reversal. The quadratic term in acceleration requires careful integration to find position. This problem involves variable acceleration and polynomial analysis. The position at reversal is positive, indicating motion before turning back.